So I don't like to just say, here's what they are, memorize these. I like to explain where they came from. So it's not like, I don't know, this feels rude to me, like, here, memorize all this stuff. So we're going to go through an explanation. We actually did do this one earlier this year. We'll see who remembers when we were graphing derivative graphs. Do you remember the envelope thing and we matched them on? Okay, that. So what you want to do is find your critical points first. That's where you have these zero slopes. And so you can put points on 0 on your derivative graph at pi over 2 and 3 pi over 2. The slope is 0 there, so we get zeros on our derivative graph. Increasing means positive. Do you remember above sea level? Decreasing means negative, below sea level. So we want to be above, below, above. So we are going to be above until we get to that point, and then below, and then above. And it's going to keep doing that forever and ever and ever. So what did we just get the graph of? Cosine. So derivative of sine is cosine. Here's what I want you to do on your little organizer sheet. List out all 6 of them. And what does d dx mean again? It means, it's instructions that mean take a derivative. Just go ahead and write out all 6. We just did the first one. Derivative of sine is cosine. All right, so go ahead back to your note part of it, and I'll show you the next one. So this is the derivative of cosine. I'm going to find where those critical points are. So everywhere I have a 0 slope. And so I can put zeros over here at 0, pi, and 2 pi. And so this is decreasing. That means we're going to be below the x-axis. And then increasing means above the x-axis. So we're going to be below, then above. So it's going to look like this. And then it'll keep doing that forever and ever. So stop and think about it. What did we end up with? It's sine, but it's what? Yeah, it's like flipped, reflected, whatever. So I think you said it. That means what do we have to put in front of it? Yeah, negative. So go back to your sheet. Derivative of cosine is negative sine. So derivative of sine is cosine. Derivative of cosine is negative sine. All still on board? All right. For tangent, this is your graph of tangent. Do you see how, well, I know you don't see them because they're invisible, but do you notice how we can put asymptotes there at pi over 2 and 3 pi over 2? You're still going to have those in the derivative graph. That's not going to change that. It's undefined in the function. It's going to be undefined in the derivative, so you can put that in. And just watch me trace along. Do you see how this is increasing? And then here, this is still increasing. And then this is still increasing. So if this is increasing all the time, we want this to be above sea level, like positive all the time. Also, you know how I put these 0 slopes in here, these critical points? This never quite goes horizontal. Do you see what I'm saying? Like, so here's what it's going to look like. We're going to be above. Don't look away. I want you to see what happens. We're still going to be above, and it's going to almost go down to 0, but not quite. Like it almost goes horizontal, but then doesn't. And then something like that. And it's going to keep being those U shapes forever and ever and ever. Does that ring any bells of what that sort of looks like? They're not technically parabolas because it's a trig function, but what one does that look like? Yeah, like I call them smiley faces and frowny faces. But which trig functions were those? It wasn't sine or cosine, guys, because those were the waves. Which were the ones that had the U shapes? Secant and cosecant. Now this one's actually secant, but what's different about it? Because usually it was like this, right? Yeah, it's not alternating. They're all positive. How do you turn something positive all the time? There's 2 ways, actually. You can absolutely value something, or you can square it. This is secant squared. It's secant, but they've all turned positive. So your derivative of tangent is secant squared. Let's talk about that squared just real quick. The reason it goes in between the secant and the x is this means you're actually squaring the secant function. Humor me for a second, because I get a lot of people that don't understand this. I want to make sure you actually know what's going on. It means this. Do you get what I'm saying? Secant times secant. If you were to write this instead, like put the squared there, what does that mean? Well, it's like of the x being squared, not the actual secant function. That's huge for the chain rule because they're different. Okay, making sure. Oops, I didn't mean to throw that. All right, after that, I don't do any more graphs. I only really go through the explanation of one more of these. You can rewrite cosecant as 1 over sine. Do you remember that from pre-calc? Okay, rewrite it as 1 over sine. And then what you can do is a quotient rule. Just took a quiz on it. Where does quotient rule start? The denominator. Good. So sine of x times derivative of the numerator. Little tricky. What's the derivative of just 1? Good. Okay, cool. Can't trick you guys. Then what? Yeah, subtract minus the numerator should just be 1. And then derivative of the denominator. What did we just say derivative of sine is? Cosine. Good. Oh my gosh, you guys listen to me. That's fantastic. And then it's over sine squared. Now I am going to clean that up a little bit. This part's gone. So what I really have in the numerator is -1 times cosine. And yes, I want you to write it that way because you'll see where I'm headed with this. And then sine squared. Oh, this is what I was actually just talking about. That's sine times sine. So just write it twice. And then I'm going to split this into these two parts. How can I rewrite this? -1 over sine. Well, that would be negative cosecant. Good. Remember your identities. And then does anyone remember cosine over sine? Good. So that is your derivative for cosecant. It is negative cosecant cotangent. So you can add that to your bubble sheet. So derivative for cosecant is negative cosecant cotangent. The other ones I'm just going to tell you, but I want to draw your attention to some things to make it easier for you to memorize. So I'm going to write them up here and then we'll talk about it. Derivative of secant is secant tangent. And derivative of cotangent is negative cosecant squared. So let's talk about how to organize that in our minds. First of all the ones that are cosine, cotangent, cosecant, what do they all have? All the cos have a negative. Do you see that? Okay. Now, usually sine and cosine goes well. That's usually not a problem. Here's what I want to draw your attention to. Do you see how tangent and secant are buddies? I call them buddies because we don't have a different word for that. They aren't reciprocals. They aren't co-functions. I call them buddies. Do you see how they go together? And then cotangent and cosecant are buddies. It's the same pattern for both of them. Tangent gives you secant squared. Cotangent gives you negative cosecant squared. It's just the co has the negative. But it's this, do you see how these are the same? Okay. And then do you see how these two are the same? Secant is secant tangent. Cosecant is cosecant cotangent. It just has a negative because it's a co. Make some flashcards. Here's the other thing that I've gotten from students in the past is just like, I got something to tell you. Do you know what I'm saying? Like over here. The P stands for positive, and you cover up the one you have. So if you have tangent, do you see how there's two S's? It's secant squared is the answer, a positive secant squared. And if you have a secant, you cover up the S, then it's secant tangent. If you've got anything better, I'd love to hear that too. So like, there they are. You have to know them. However you put them in your brain is what you got to do. Okay. So go ahead to the other side of your note sheet and we're going to try a few of them. There it is. Now, as a pep talk, Power rule didn't go away, product rule didn't go away, quotient rule did not go away, and chain rule did not go away. We brought all of those with us. We just now have trig with them too. You all look excited. Okay, so what rule do we need for this person? Start all the way over to the side because it's going to be long. I'll color code for us. What rule do we need for this one? We will need a power rule, that's true. Product rule, good. Okay, so the x squared is the first thing. The sine of x is the second thing. So how does product rule start? Yeah, x squared, the first thing, times derivative of the second. All right, what's derivative of sine? Cosine plus the second thing times derivative of the first. 2x. That's it. We're not going to simplify any of these. They're all going to be a big old mess. What rule do you need for this one? It is chain rule. Chain rule and product rule get mixed up a lot. Now, if there was a cosecant of x times something else in parentheses, but it's not. It's like cosecant got hungry and ate that whole thing. Do you get what I'm saying? Okay. The outside function is cosecant. The inside function is the stuff in the parentheses. All right. So again, start all the way over here. We do the derivative of the outside first. We leave the guts alone. So what's the derivative of cosecant? And you don't have it memorized yet because I literally just told it to you. So look at your bubble sheet. Yeah, now it's negative cosecant of that stuff, cotangent of that stuff. The guts doesn't change. So it's negative cosecant cotangent. The guts doesn't change. It's negative cosecant cotangent of said stuff, like of those things. Now, unfortunately, that's right where the hole is in the paper, but I can make it fit. Chain rule dot, and then you chain on the derivative of the stuff in the parentheses, which would be what? 4x. Good. Cool. All right, let's try another one. What rule do you need for number 3? Now, this has 3 links in the chain. The most outside function is the 4th power. Inside that is cosine. And then inside that is the 9x. Remember bringing up the cartoon where like a medium-sized fish eats the small fish and then a big fish comes and eats both of them? It's that, okay? So we're going to do the power first. You're going to bring the 4 down. It'll drop to a 3. And everything else stays the same. The guts all stays the same. So it'll still be cosine and it'll still be 9x. We brought the 4 down, it dropped to a 3. Chain rule dot. Now the next inside function is cosine, and here's the thing that gets people. They all want to put a power on it. We just did the power, we took care of it, it's done. We're just on to cosine. So you don't have it memorized yet. Look back at your sheet. What's derivative of cosine? Okay, but it's going to be negative sine of, what's the insides? 9x, good. So it's negative sine of that stuff. And then one more chain rule dot. Now you're going to do the derivative of 9x, which is just 9. All right, so look at number 4. This is 2 separate things. So we're going to do the derivative of this first part minus, and then the derivative of the second part. All right, so what is your derivative of secant? You don't have it memorized yet. Look back at your sheet. Secant tangent. There is no chain rule, no product rule, nothing weird. It's just secant of x. So it is just secant x tangent x. Like that is literally just what's the derivative. Minus, now this one's a chain rule. It's exactly like what we have up there, but instead of like something in the parentheses, it's just x. So there's actually only 2 links in the chain. What's the most outside function? 2. So we're going to put 2 and it's going to drop to a 1. I strongly suggest you write the 1 because when it disappears, people get confused. They're like, where did it go? And then you're going to chain on, little dot, the derivative of tangent. So derivative of tangent secant squared. Good. And these are two separate terms. There's this minus this. There's two separate things separated by a subtraction. All right, what rule is this one? Quotient. How does quotient rule start? Denominator. Good. So cotangent x times derivative of the numerator, that would be 4 minus 4x, the numerator. Derivative of cotangent. There's not a chain rule, nothing weird. It is literally just cotangent x. Good. Negative because it's a cosecant squared over cotangent squared. Couple of rules in this next one. What do we need? What rules do we need? There will be a product rule. Good. Identifying the rule is like half the battle. You guys have got that. All right. So this sine of 5x squared is the first thing. Secant is the second thing. But do you see how this will be a chain rule? Because it's not just sine of x, it's sine of stuff. Okay, cool. So this will be the first thing. And I'm not going to be able to fit this. It's going to go down to the next line. Like there's no way. It's going to be like really long. All right, so first thing times derivative of the second. So derivative of secant tangent. And again, there was no chain rule, nothing weird. It was literally just derivative of secant. Wow, that parenthesis turned weird. I'm going to fix that. All right, and then what comes next in our product rule? First, derivative of the second. Plus, good, and I'm going to have to come down to the next line. The second thing, secant x, times derivative of the first. Now, this is where the chain rule comes in. Sine is outside, 5x squared is inside. So what's your derivative of sine? That's the outside one. Good. So it'll be cosine of 5x squared, chain rule dot, and then your derivative of 5x squared is 10x.